In this video, I'm going to show you how we designed the X-Beam flight case, which we cut on SmartBench. If you would like to see the video on how we made the flight case, it will be linked in the description below. So I hope you're sitting comfortably. Let's get started. So I'm going to go into creating a new file. And the first thing we're going to do is set up a full 8 by 4 foot sheet. And our stock is 12 millimeters thick. So we're going to dive straight into the Gadget area of VCarve Pro, and we're going to go down to Box Creator. Now, I want to show you an example of how Box Creator kind of functions. Now, the first thing I'm going to do, it's going to throw up an error, is because our box components will not fit completely on this sheet. Okay, so these are our basic parameters. We're going to create all sides to our cube. We're going to be using a 5 millimeter end mill for this one, and I would like a tab lid, and I would like square tabs. So for this particular box, we're going to make an allowance of 0.1. You are probably going to need to play with this allowance feature to get your finger tabs to fit exactly how you want them. So you'll notice it's now saying that it couldn't arrange quick enough, which basically means all of these parts don't fit on this sheet. So I'm going to delete the toolpath that is created, and I'm going to flash up and I'm going to delete all of the parts. Now, the quickest and easiest way to get around this is to create a much bigger workspace. So I'm going to change that to 8 by 8 square, and that should be big enough now. When I go back into our Box Creator gadget, it's kept our 1685 in width, our 375 in height and depth. It's kept our joints. We just need to re-input the 0.1 allowance. We want a tabbed lid, and we want square joints. Now what it's done is it's repopulated all of our parts. So I'm going to pick those up and I'm going to turn those 90 degrees. And if I come across to our tool path and recalculate that, that's now going to recalculate all of our parts together. So for this exercise, I'm just going to drag it down to here, out of the way. And I'm going to come back over to our job dimensions, and I'm going to change that back to an 8x4 sheet. Okay, so that's a really easy and quick way to cheat the system and effectively get what you need. All right, so you can see there's all of our 50 millimeter tabs. There's all of our box components. So the next step is going to be creating some smaller boxes, which is going to sit on the inside of our flight case, and that will be used then to hold our X-Beam in position. So for this box, we are going to have a width of 400 millimeters. We're going to have a depth of 95 millimeters. We're going to have a height of 80 millimeters and a joint width of 20 millimeters. Again, we're going to have the same 0.1 allowance. We're going to use the same 5 mil end mill. And again, selecting the square tabs and a tab lid. And you'll see there as our parts. So we'll orientate those by 90 degrees. And we'll drop those there. Okay, again, I'm quite happy to delete this pre-predicted toolpath because we're going to do something quite clever now, which is we're going to re-nest, and we're going to use VCarve then to tell us how many components we can fit into one sheet. So if I start at the bottom right of my screen, hold the left mouse button down and come up and drag and select all of those parts, I'm going to come across to our nesting function. Okay. So we'll start off at the top. We've got our 5 millimeter tool. We want to create a clearance between each part of 8 millimeters. And we want a border gap around the edge of our sheet of 20 millimeters, which is going to allow us then to fix our sheet down. Now, just be warned, if you're going to try and cut a part, which is full 8 on the sheet, by having the border gap of 20 millimeters, it won't allow you because it believes that part will no longer fit on your sheet. So we're going to allow it to rotate our parts by 90 degrees for best fit. And we want a number of copies. We want just one for the time being. So we're going to select apply. And if we preview that, that will then bring up sheet 2, which has a number of our parts, and then sheet 3. Okay, so I'm fairly happy with that for the time being. However, I'm going to make some changes. So this part here, I actually want on sheet 2, which is going to be our lid. So if I hold Control and press X, then double click on sheet 3, and then hold Control again and press V. That's now copied and pasted that part. I'm now going to select these parts for our side piece. I'm going to hold Control and press X again. I'm going to come back to sheet 2. I'm going to hold Control, press V, and then I've got the parts in the correct orientation. So this will be our base, and this will be our 2 sides. This is going to be our ends, and this will be one of the internal boxes. And again, I'm just going to shuffle this around to get it just how I want it. And then effectively we have a top and base and the 2 sides. Now I need 2 of these internal boxes. So if I just bring this along, shuffle it around so it's reorientated for me. I'm going to select these and hold Control and press C for copy and then V for paste. And I'll move these bits along here out of the way, just so I know what I'm looking at. And I'm going to hold Control again, press C and V to recopy these parts. And now I'm just going to shuffle these around and reorientate them so they fit on our sheet. Okay, so very simply, that is the main components of our job. We're now going to start to add some of the different features to make this flight case function. So I'm going to start by adding the handle holes for our flight case handles. So those handles holes are going to be 130 millimeters by 80 millimeters tool. And I'm going to drop one in there. I'm going to drop one in there. So if I start by selecting our first handle hole and then holding shift, I'm going to select the actual vector. I'm going to come over to our alignment tools and I'm going to center the object within this vector. So that's very, very simple and easy. Again, I'm going to select this handle hole and I'm going to select this vector. And again, I'm going to center that one. That's those objects done. The next thing I need to look at is then going to be the cutout apertures for our flight case wheels. So I'm going to create a square with square corners. And I want our, well, I'm actually creating a rectangle. I want our rectangle to be 35 millimeters on the x-axis and 55 millimeters on the y-axis. And again, I'm going to drop one there. I'm going to drop one there. I'm going to drop one there and one there. So with a little bit of shuffling, I'm going to select one of my flight case wheel apertures and I'm going to select the vector which it will sit within. And I want it to sit in line with the bottom. All I'm going to do now is using the direction keys on the keyboard is I'm going to shuffle this into place so it sits bang on this vector line. So you need to zoom in and zoom in and zoom in. Once you get used to doing it, it's not too bad. It's a little bit fiddly at first. Okay, so I'm really happy with that. As I zoom in now, I'm very, very close. I'm onto that line. So you'll notice the new vector, which we're going to cut, our little internal profile, sits perfectly in line with the bottom of the vector. And I'm going to orientate it to sit inside of this tab here. So we'll do exactly the same again. We'll select this hole. Holding shift, we'll select our outside vector. And we'll use align to the bottom. And we'll just nudge that across until we're happy with the placement where these two vectors are sitting smack bang over the top of each other. So again, for these bottom wheel cutouts, we'll follow exactly the same principle. We'll select it to the top. At this stage, I've got all of the main components designed for the outside of our flight case. And I've also designed the inside parts which are going to hold our X-beam inside the flight case. We've created now some of the different handle hole features and the internal cuts then for our small wheels. We're going to go ahead now and we're going to design the extra auxiliary parts which are going to go inside the flight case and hold all that X-beam in place while you're in transit. So the next part I'm going to design is going to be some plates that will sit inside of the X-beam and hold the upper part of the X-beam into the flight case. So we're going to have two parts at 180 millimeters on the X-axis, and they're going to be 390 millimeters on the Y-axis. So I'll drop one there. We're going to make some modifications to this to fit over the inside of our X-beam, there's a small electrical feature that sits there. And what we're going to do is we're going to create a cutout on all 4 of the corners on both parts. So no matter how you've got this part configured, you're never ever going to clash with it. So I'm going to make a small extra box, which is going to be 15 millimeters on the X-axis and only 10 millimeters on the Y. And we'll just copy and paste. And we'll set one up for each of the corners. And again, using the alignment tools, very simply, we're going to select our part, we're going to select our outer vector, and we're going to drop those into place. Nice and simple. And it's accurate as well, that's the main thing. So if I start again down the right-hand side, holding the left mouse button down, I can select all of those. I'm going to come over to the subtract second selected vectors. And what it's done is very quickly, it's cut out all of those extra vector lines that we didn't want. So that's nice and neat and an easy, quick way of doing it. So we're going to cut some holes in this box now. That is going to sit over some internal bolts. So we want a 9mm hole. No, sorry, a 9mm hole. So we'll select that one there. And these holes are going to be offset, which will give you a center measurement. They're going to be offset by 261 millimeters. So I've got both of those holes there. I'm going to group those. For the moment, I will just center them into my board. Okay, so now I'm going to take those holes, and again, I'm going to select our outside vector, and I'm going to center those 2 holes to sit within this little fixing plate. Okay, so nice and simply then, I'm going to grab both of these. I'm going to press G on the keypad to group them together, and I'm going to nest them. Am I going to nest them? No. Then I'm going to array copy them. I want 2 of those on the X-axis, and I'm going to gap them to be 7 millimeters apart. Okay. So nice and simply, we're going to do that. And I'm just going to pick up all of these parts now, and I'm just going to move them across so they're closer to minimize our offcut. And if I press U, that's then going to ungroup those parts again so they can all be moved singular. Okay, so now I've got those parts designed. I'm going to pick them up, and for the time being, I'm just going to move them off the sheet, ready for some better orientation later. So the next stage then is to create some strips that is going to sit on the inside of the lid, and will just help sort of keep everything nice and firm when it's all together and help you align the lid when you're putting it back on. So the first part I'm going to make will be the long strips. So they are 1,661 millimeters in length. I'm going to make all of these strips 60 millimeters wide. So again, if I drop one of those onto my sheet, I can then select this first vector and get that to run nice in line. So all of our cuts will be nice in line. And I'm going to pick up this one, and again, using the array copy, I'm going to ask for it to copy 2 of those across the X-axis with a 7 millimeter gap. So we've got both of those. I'm going to bring them along and just move them closer now to our lid part. I don't want to move them too close because I'm going to have these little square parts left on our sheet. So if I move these too close, then these will become small little cubes that might pop out of your sheet and interrupt your cut. So the next step is to create the little width strips. So again, keeping that X-axis at 60 mil, we're going to change the Y-axis to 328 millimeters. And again, for the time being, I'm just going to drop one over here, move that out of the way. I'll select this one again, and we'll just get that to run in line for the time being. Very simply then, I'm going to pick up that one vector, come back to our array copy, and using exactly the same parameters again, we now have 2. Okay, so I'm now going to start to orientate those on our sheet, and I'll pick up all of these parts again, and I'll line those all up. Now, what I can do is I can make a 7 millimeter long box and just drop it there. and use that to start to align our parts. So I've got my 7mm box added. I'm going to nudge that up against this vector, and I'm going to select this one and our little scrap 7mm, and just bring that across so that's nice and efficient. So we've got nice, even 7mm gaps on everything. And again, I can bring this down and I can pick up these two vectors and group them together and get them to align nice and neatly with our 7mm spacer. And for the time being, I can just delete that 7mm spacer and I've got nice, even 7mm parts around everything. So I'll just bring these parts up a little closer and we'll ungroup those. And again, I'll come back to these spacer parts for the time being and just ungroup them. There we go, nice and simple and an efficient use of our sheet. So the last thing I would like to create is now some spacer packers, which are going to sit on the inside of our little lids. And those little spacer packers then are just going to create a gap between our X-beam and our internal boxes for our nuts and washers to sit. So I'm going to want 4 of those. So the first thing we'll do is we'll create one, and they're going to be 35mm wide by 370mm in length. And we'll drop one down there. And again, using our array copy, I will select 4 of those. Nice and simply, they've all popped down in line. So I can select all of these 4 and I can just nudge them along till they run in line with all the rest of our parts. I'm making sure I've got adequate spacing on the y-axis then, just so I can add some tabs for some strength. That is all of our internal accessories created then, which is going to finish off the inside of our flight case. So now we're going to go back to our second sheet firstly, and we're going to create some very simple toolpaths. Okay, so you'll notice any vectors we create with the box gadget is going to be the actual box vector itself, and this secondary vector with this small line here is going to be the line that will create our toolpaths on. So I'm just going to hold shift down and I'm going to go and select each one of those vectors one at a time. Okay. Okay, so now I've got all of those outside vectors selected. I'm going to go to Profile Toolpath, and we are now going to mimic exactly what the box creator gadget will do. So I want to cut 1mm into my spoil board. So I'm going to make sure I've got a 13mm depth of cut. I'm going to select my 5mm end mill, and I'm just going to check that I've got 17,200 RPM. I'm cutting it 2.5mm per pass, and I'm running at a feed rate of 4,500mm a minute, or 4.5 meters. And I want to cut on the line. Okay, so that's very specific in regards to the box creator gadget. That cutter is going to straddle the line and cut on the line. Okay, I'm not going to do a separate last path because that's going to make our box effectively smaller. And I'm going to create some tabs at 6mm high by 20mm in length, and I want those to be 3D tabs. Okay, so the box creator gadget is now going to throw up all of these tabs. And in a minute, I'm going to go around and I'm going to reselect and deselect certain tabs to get everything exactly where I want it, because A, there's a lot, and B, I'm not happy with the placement of everything. But for the time being, just to make sure we've got some tabs, I'll leave that selected. And I'm going to select ramps. I want a smooth ramp, and for this particular project, I'm going to do it 8mm in length. Now, as I press calculate, it will throw up the warning to say that I'm going to cut through my material, which is okay. And now it's going to project my 3D model to show my preview. Okay, so as you look at the sheet, we've got all of our parts laid out. We can make sure there's no big blank spaces, which means certain vectors haven't been selected by accident. I'm going to come back in and I'm going to double click on this toolpath, and I'm going to go to Edit Tabs. Now, I don't want 4 tabs in the corners. It's too much. And as you see, this 20mm long tab will effectively try and wrap around the corner, which is just going to make your life really difficult in regards to cleanup. So I'm going to take these tabs away, and I'm going to add the tab there, and then I'm going to move this tab over to here. So I've got the 2 tabs running in line. That's going to allow and add extra strength to our project. Also, because these box parts are so long, I'm going to add some separate tabs in the middle. And again, what I'm going to try to do is line these tabs up so the strength of the wood is left going in nice straight parallel lines. Okay, that will be really important then on all of our parts where we created our 7mm gaps. So I'm just going to go down through, reselect and deselect the tabs where I want them. Okay, so at this stage, while all the external box profile cuts are already in the memory of VCarve, I'm going to come across to sheet 3, and I'm going to set up the toolpath then for this lid, which again, just roughly check in, is 13mm deep, 5mm end mill, cutting on the line. And we want to add our tabs, we want to add our ramps. And again, I'm just going to quickly reselect these tabs to be where I want them. So again, just avoiding these tabs in the corners and getting those tabs in those nice straight sections there. So I'll throw some tabs down here as well, just roughly in the middle of our sheet. Okay, I'll just name this one box lid. So if I preview this file here, you can see there's our cut going all the way through. There's our nice little fillets in the corner. There's all of our tabs. Okay, so I can jump back to the first sheet, finish that one off nice and simply now. Holding shift, I'm going to select each one of these vectors, which these will be for our internal cuts. And I will create a profile cut, cutting on the inside of our line. Same tool, same size tabs. Call this one then inside cuts. And again, we'll use the same ramping strategy. So all the strategy is exactly the same. Okay, so there's our inside cuts now orientated on our sheet. All right. So the last toolpath to do is going to be for these extra accessories now. So you'll see now why we've created these different 7mm spaces around everything. So again, if I start at the bottom by holding the left mouse button, any vector I'm touching will be highlighted. So you can see because I wasn't touching these top left holes, you just hold the shift and just pick those up. So I'll select the profile path to cut outside of the line. We're going to select our tabs. We're going to select our ramps. And now what I'm going to do is I'm going to select an area where I can fit these tabs in right next door to each other. So as each part is cut out, the tab then will be adding the support, bridging the gap between them. And this is if you're looking at sheet efficiency and trying to use as least stock as possible, this is the most efficient way I've found to do it. So bear in mind, I've got a 5mm tool, and that's going to run a 7mm slot in between them. So it's just going to skim those edges and clean those up as it goes. Okay, so as I calculate these final toolpaths now, you'll see they become part of our preview. Okay, so if I zoom right in here, you can start to see now where we're going to have our bridging tabs connecting and adding support back into this stock. But you can also see we're going to have a section here where these parts are going to be cut away. So if I go back into this profile toolpath here, edit our tabs, you can see where I've missed one. So it's always worth going over and analyzing your 3D toolpath, your 3D preview, just to ensure that you're not going to have any parts coming loose then as you're cutting away at this sheet. Okay, so if I start at the top by holding control on the keypad and holding down the left mouse button, I'm then in a position to move my preview around so I can really analyze that. I've got a tab, 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 tab. That's all nice and bridged. I've got tabs down here bridging all this together. I've got tabs down here bridging all this together. So all of our material is going to be nice and supported all the way around. We've got our box components then are going to be nice and held into place. And also what I'm looking out for as well is to make sure that these tabs aren't sitting going around corners, because it just makes it really difficult then to clean up and get a nice finish. So if I turn it this way, then you can see then all of our lines. So we just got our last toolpath to create for this sheet, which will be these internal pockets here. So again, same 5mm end mill. I'm not even going to bother with ramping these cuts. And what I found in the past is you can edit your passes then. So this is going to come down in 2.16mm increments all the way for our 12mm sheet. So what you can do is you can edit the amount of passes it will do. And that's going to do it in 4 passes now, which is 3.25mm per cut, which is more than ample. So I'm not worried about a ramp. I'm not worried about any other features. I'm just going to press calculate. So as you can see now, our SmartBench is going to start from our datum. It's going to move across and it's going to peck and pocket out each of these holes in that rotation order. Nice and simple. So just for easy toolpath management, I'm going to come down and I'm going to rename these. Okay, so I've got my toolpaths named. I'll just come back over to this sheet and I've got my box parts to rename. So as you can see, we've cut down all of that cutting into 2 separate toolpaths, okay, using all of the same cutter. So as you come back over to this second sheet, you can see again, we've cut everything down into 3 separate toolpaths, again, using all the same cutter. So if you wanted to be efficient in regards to your toolpath strategy, you can effectively come over to your save toolpaths and you can select this middle option, which is visible toolpaths on one file. And you can then select the order of cut all of the outside box features and then cut all of the internal parts. Alternatively, you could pick up this toolpath, move it to the top. Then as you select it, it would cut all the internal cuts first, all the external cuts. So you've got ultimate options then to move everything around to do things in the order that you feel is the most appropriate. Okay. And also as I select the 3D view, if I click on my tool paths, it's going to show me all the paths that the CNC is going to make. So all of these red lines are what are called your rapid moves. So it will start to show you in what order these different things are going to be cut. So the machine's going to move up from our datum, move down to this one, across, up and across. So again, you can always go into the tool paths and change the vector selection order to get it to run exactly how you want it to function. Okay, so just as a recap, you can come over to save. You can save each toolpath then as a separate entity if you wanted to break it down into separate parts. Again, you could go into this box parts and you could separate this so it cuts those 2 in one file, cuts this on one file. You can play around with it, get it exactly as you want, but the most efficient would be to select the visual toolpath in one file and select both of those, and as you press save them for your G-code, that's going to save that into one nice neat file for you. So there you have it, folks. That is how we designed the X-Beam flight case using VCarve Pro, which we cut using SmartBench. If you would like to make this flight case yourself, please follow this tutorial, or alternatively, you can download the file free of charge in the description below. But thank you very much for watching. Hope to see you again on the next one.